This is Algebra 1, Lesson 25, Solution of Equations. We're going to be doing examples 25.1 through 25.6, and we're going to be solving two-step equations. Now, I hope you watched the video right before this in this Lesson 25 playlist. It's the first video in the playlist because I go into detail about why we're doing what we're doing. Now here, I'm just going to do it, okay? So I'm going to briefly tell you how you can make a list to do this, okay? Now, if you knew what the value of x was, we don't, okay? But if we did, we would substitute it in this equation, right? We would put whatever that number is in there, and we could work that out to see if it's equal to 17, right? But since we don't know what it is, okay, we're going to have to solve the equation. So let's write out what we would do if we did know, okay? If we did know x, the very first thing we would do is we would multiply it by 4. And then the second thing we would do is we would add 5 to it. And then we would know, hey, did we get 17? Did it work? Okay? Now, we're going to do the opposite and in reverse. So our step 1 is going to be, instead of adding 5, we're going to subtract 5. And instead of multiplying by 4, we're going to divide 4. And that'll be our second step. See, we're going to follow it backwards and the opposite. So first step, subtract 5. Okay, we subtracted 5 on both sides to keep it balanced. Second step, divide by 4. Both sides to keep it balanced. And we can check it. 4 times 3 is 12, plus 5 is 17. We got it right. Okay? Here, if you knew what m was, the first thing you would do is multiply it by -5, and then you would add 6. You would multiply by -5, and then you would add 6. We're going to go backwards, and we're going to say this is our step 1 now, and this is our step 2, and we're going to do the inverse operation. So instead of adding, we'll subtract. Instead of multiplying, we'll divide. Okay? So our first step is going to be subtracting 6. So you're always going to add or subtract first on these. Subtract 6 to make it go away. Subtract 6 on the other side to balance. -5m equals 2. All right, next I'm going to divide by -5. And I get m is equal to, that 2 divided by -5, you could just put the negative out front, okay? Or you can put it in the numerator. I think the book will usually have it out front. Let me check that. They will usually, yes, they wrote it out front. Now, they do have a note here that you can handle the sign separately. So I'm going to show you something here. I'm going to kind of come out. When we got to this step here, some people are really bothered by that sign. So what the book says you can do is, hey, I can get rid of this negative sign over here if I just multiply this by -1. But I just messed up my equation, didn't I? By multiplying one side by something and not the other. So let's multiply this side by -1. And as long as you're multiplying both sides by the same thing, it's totally legal to do. Now, what did that accomplish? A negative times a negative is going to be a positive. And then here, you've got this negative times a positive. That's going to be a -2. So what that did is, when I go to isolate the m, to get the m by itself, I'm still doing the same. I'm still going to get the same answer. But the book says that some people have less trouble with the sign if they deal with it separately. Okay? This is the way I usually do it here. Okay? But the book recommends that if you're having trouble with signs, you can do it this way. Okay, now we end up, either way you want to do it, we end up with -2/5 is your answer. And you could substitute that back in and you will see that it works. All right, let's do 25/3. If you knew what k was, you would multiply it by -7 first. Then you would subtract 4, right? Or add a -4. Now, we're going to go backwards. We're going to start here and then go here. And we're going to do the opposite. Instead of subtracting, we'll add. Instead of multiplying, we'll divide. So let's add 4 to both sides to get that variable by itself and to balance our equation. Signs are different, so we subtract, take the sign of the one with the largest absolute value. Now here, you could do the little trick of multiplying both sides by -1. You're really just changing the sign of both, and that is totally legal if you do it on both sides. That would be totally fine. Then you can divide both sides by 7. So notice here in my steps, I said divide by -7, but I took the little shortcut with the book and I divided by, or multiplied both sides by -1 and then by 7. Okay, so it's the same thing. All right, when I divide both sides by 7, I get 17/7. And you don't have to do that little thing that the book does, okay, but you can. All right, 25.4. Here, if I knew what p was, I would multiply by -11, and then I would add 5. Right? Multiply by -11, then add 5. All right? I don't know what it is, so I need to go backwards. I need to take the shoe off and then the sock off, right? Or untie it, then take it off, right? All right, so I'll change the order, and I'll change and do the inverse operation and follow it. So I will subtract 5 first on both sides. And I get -11p is equal to 12. Then when I follow my next step, I'm going to divide by -11. Or you could do what the book does and change both sides. P is equal to -12/11. And that's your answer there. Okay? 25/5. If you knew what m was, you would multiply by 1/5. And then you would subtract 1/2. You'd multiply first, and then you'd subtract. Okay? We're going to follow it backwards. And we're going to do the inverse operation. So we are going to add 1/2 to both sides. And that's going to balance it. That leaves me with 1/5 m is equal to. Now, I can't do that computation until I have a common denominator, because we're adding fractions here. What's my common denominator? Well, I've got a 4 here and a 2 here. I can make this one become a 4. So I'm going to write this 3/4. Multiply that by 2. That becomes 2/4. So let's add 3/4 and 2/4. And we get 3 plus 2 is 5/4. Okay? So we took care of this step. Now we're going to divide by 1/5. Now, it would be totally fine to write it like this. Divide by 1/5, divide by 1/5, and then you have this problem, which is 5/4 divided by 1/5. At that point, you would keep change flip. 5/4 times 5/1. But I want to show you a little bit easier way to do it. We know that dividing by a fraction is the same thing as multiplying by its reciprocal. So we're dividing by 1/5, which is the same thing as multiplying both sides by 5. That's a lot less to write, and it means mathematically the same thing. Those would cancel out because this is a 5/1. and we have m is equal to, and then we will multiply 5/4 times 5. The 5 is over a 1. So that's 25/4. And you could leave that as a mixed number. Okay? Now, like I showed you at first, if you wanted to divide both sides by 1/5, you would get exactly the same answer. Okay? All right, example 25/6. This is our last one for this set of examples. If I knew what x was, the first thing I would do is I would multiply by 4/10, and then I would subtract 2/10. So let's follow it backwards, and instead let's add 2/10, and let's divide by 4/10. Okay? So we're going to add 2/10. Remember, we're always starting with the adding first. Adding or subtracting. We get 4/10 x is equal to. Now, notice this here. I want to make, when I do decimals, adding and subtracting, I usually will add zeros to make them the same length, because you can add zeros all day long after that decimal at the end, and it doesn't change the value, right? So I can see that the bottom number is larger, because look at the place value. Okay, you've got 2/10 in the bottom one, and you've only got 1/10 up there. So I'm going to turn this around, okay, so that I can think about it this way. If you don't have to, you don't need to. But I think for most people it's helpful to be able to do this. And then we can borrow. Okay, now which one has the largest absolute value? Well, it's the 2/10, this one, and it was positive. So that means this is going to be positive. Okay. All right, next we're going to divide by 4/10. Now, before I divide, do you notice something here? I'm multiplying 0.4 by something that really just moves the decimal one more place to the left, doesn't it? So you may know what that is right now. But if you don't, it's okay. Let's divide both sides by 4/10. And I get x is equal to. Now, how do I do this? Okay, there's several different ways to do it. I think maybe the easiest way to show, and if you can think of a different way, that's fine. I'm going to do it like a long division, top number divided by bottom number. Can't divide by decimal, so I'm going to multiply this by 10 and move it over. Multiply this by 10 and move it over. So essentially what it is now is this. Oops, I put the decimal in the wrong place. 0.004. So we really don't need all those zeros, do we? Okay, and then the decimal is here. So it's here, and that means I bring it up. 4 doesn't go into the zeros, but it will go into 4 one time. Okay, you can review your computation there if you need to, but there's your answer. And that makes sense, because if you go here, 0.4 times something makes it 0.04. Well, the number didn't change, just the decimal. So I must have been multiplying by 1, and it made the decimal move one more place to the left, so it was 0.1. Okay, so your answer is 1/10.